All right, today we're looking at sigma notation or limit Riemann sum notation. Essentially what this is a way to represent a Riemann sum as an integral. Now, we already know a Riemann sum approximates an area under the curve, and the integral gives us the exact area under the curve. So the idea is, if we have an infinite number of Riemann sums, then it should equal the integral. And that's where this formula comes in. This is our information. If you were in class, I'd go over where we got a lot of this information from. But for now, it's just you need to know that we know that the change in x is b minus a over n. And we know that x sub I is a plus delta x times I. So our integral from a to b is going to be the limit as n goes to infinity, so as the change in x gets closer to 0, of the sum from I equals 1 to n, so the first x value to the infinite number of x values, the y value there times the change in x. That's what this formula represents. Now, the types of problems you're going to ask are wildly different. A lot of times it's going to be something like, here's an integral, represent it as a Riemann sum. So we're finding the exact area under the curve, which means finding the integral from 0 to 2 of x plus 1 dx. We have x squared over 2 plus x from 0 to 2. Plug in the upper and lower bounds, so 4 over 2 plus 2 minus 0, which is going to be 4. So there's the exact area under the curve, and then write a summation that represents it. Well, we need two things. We need delta x, which is b minus a over n. N just stays as a variable. B minus a is going to be 2 minus 0, so 2 over n. And we need x sub I, which is a plus delta x times I. We just found delta x, so it's going to be 2 or 0 plus 2 over ni, which is 2 over ni. And last but not least, we need f of x sub I. So that means we're going to plug x sub I, the 2 ni, into our equation. So it's 2 over ni plus 1. Now this is not the I that's like the square root of negative 1. This is just a value that we use in summations. So now we're going to plug all this into our limit sum notation. So 4, the area under the curve, is equal to the limit as n goes to infinity of the sum from the first term to the nth term, which, as we said, n was going to infinity, of f of x sub I, which is 2 over n. Oops. There we go. 2 over ni plus 1 times delta x, which was just 2 over n. We could distribute this in as well if we wanted to, but we don't need to. This is what we're looking for. Okay, this is the whole idea behind this. It's that this limit, this sum right here, is representative of an infinite number of Riemann sums, and that's equal to the definite integral, which is the exact area under the curve. Okay? If you want another practice you can try this one. Aside from that, let me know if you have any questions. See y'all guys next time.